Hello students, today's agenda is to check your homework and we're going to be learning about step and wise and piecewise functions, and we'll be working on 11.9. Today's students will be able to graph step and piecewise functions. So first of all, what is a step function? And so a step function is a graph formed by a series of line segments which look like steps. And so we have here the equation of a step function. It's also called a floor graph, function, sorry. Okay, and so what does it look like? So and we have a graph like this. Let's say that you're renting an apartment and they say, oh, the first month is going to be free. So you're gonna pay, so we have for the X is months, for the Y is money that you pay for rent. And so the first month is gonna be free, so come first month and then you're gonna have your first payment. But that means that it would look like this. Then let's say that you're paying $2,000. Again, you pay it once and that $2,000 stands for the whole month, but then at the end of the month is not $2,000 anymore, but now a new month has come and now you have to pay another $2,000, meaning a total of $4,000. You make the payment up front, right? And again, that's good for the whole month, but then at the end of the month, another month comes and it's not $4,000, but now it's gonna be $6,000, which is good for the whole month. But again comes the next month and now it's not 6,000, but you have to make the new payment to make it 8,000. Okay, and so this is what it's called a step function, meaning that you make the payment and it's good for the rest of the month. You don't keep paying each day, right? And then get to the next month and continue to make payments, but rather it's good for the whole month and then it goes to the next. Okay, so now notice the notation here. For the step graphs, it looks like an L and a backwards L. And then you have other instances where you might have, let's see, you're paying for either gigabytes or postage for a letter, or payments where you start using it and you don't pay until you start using the first part of the next one. So that's this notation where your L is not an L, but rather, I don't know, this kind of markings. And so your graph would look a little bit like this. What should we do? So let's say that you start paying, let's say, I don't know how much is postage right now. Is it 30 cents or 40 something? I remember the last ones that we used was 39, I believe. And so even if you don't have 1 ounce, let's say that this is ounces and this is money that you pay in cents. Even if it's not a whole ounce, you still pay. But if you don't have anything at zero, you don't pay anything, right? So that will be an open circle, and you start paying even if it's half an ounce or 3/4 of an ounce. You start paying that first postage. Okay. And then let's say that it goes a little bit over, it's 1 ounce, you still pay the 39 cents, but then it goes to, let's say, a little bit more. So if it's 1 ounce, you still have the 39 cents. But then as soon as you get a little bit over an ounce, like 1.1, you pay for the next ounce, as if you're paying for the 2 ounces. Okay, so it doesn't matter. In here, the 1 ounce is still 39. That's why it's open for the, what would it be for 2? 39 plus 39 is 78 cents. And then for the next one, again, if it's 2 ounces, you still have to pay only 2 stamps. But if you go to the next one, which makes it, let's see, $1.17. And so again, it's opening here because it's still at 2 ounces exactly. You don't pay the third stamp, right? You just put 2 stamps. And so the notation in here is when the circle is open at the beginning but closed at the end. And so look at the structure of the equation. You don't have an L but a upside down L, and the backwards L is also upside down. Okay, so I want you to check out the difference between the two. This one is like this for function, and then these ones are, I don't think they're called roof functions, but okay. So that's the idea of step functions and what they refer to. Also gigabytes. If you spend only 1 gigabyte, maybe you will pay $15, and then after that, as soon as you go over the gigabyte, you start paying for the next one. Even if you don't completely use the 2, you still pay for 2. But if it's only 1, this is open circle because you still will be here paying only for 1 gigabyte. Okay, now let's look at piecewise. Piecewise are going to be graphs that look, let me see, you're going to have different graphs going on at the same time in the same, let's say maybe you can have something like this from here to here, and then something like this maybe, and then I don't know, maybe something like this. So that's what it refers to piecewise, because there are different pieces in the graphs, and it's because it has a combination of different equations in here with certain limits in the graph. So let's look at this one specifically, and I'm going to be color coding these ones. So my first equation is going to be in blue, my second equation is going to be on Y, and my third equation is going to be on green. And the reason is because that's going to make it easier for you to follow, hopefully. Okay, so what I'm going to be graphing with the colors is going to be my actual whole graph without paying attention to this. But then with the limits, I'm going to tell you how to find that out. So let's see. Let's say that I have this graph. Okay, and you can be doing this as I do it too. And so it says that my initial point is at 3 and that my slope is 1 over 1, because if there is no coefficient, the rise is 1, the run is 1. So it's 1, 2, 3. And so 1 over 1, 1 over 1, 1 over 1. And so if I go on the other direction, it's also -1, -1, that makes it +1. -1 makes it +1, -1 makes it +1, etc. So my line, basically, if I didn't have those limits, those limitations right there, this is my line. And as you can see, it's as perfect as always. Okay, but then it says that x is less than 0. So I'm gonna use a ruler because it got a little confusing. When I'm saying x, it means that these are greater than 0, this is 0, and these are less than 0. So in here it says x is less than 0. So I'm not gonna look at the ones that are greater than 0. And so I'm gonna put less than 0, okay? I'm gonna put my circle here. The other thing is that from before, you have learned that if you have an equal sign in here, we close the circle. But since it doesn't have an equal sign, it means that the circle is gonna be open. And so, again, my x less than 0 are on this side, so my graph is only gonna be on this side. Okay, only the part with an open circle because it has no equal sign underneath of the inequality symbol. Okay, so for y equals 5, I'm not gonna look at this. If I was to graph y equals 5, it just means that I'm gonna have a line at 1, 2, 3, 4, 5 on y. And this is my graph for y equals 5. Only y equals 5, that's my line. However, this limits me to only the point, and I should be circling with the same color, only the point when x equals 0. So this means only this point. So I'm gonna put my circle in here, and basically that's it. This is not part of my graph because this is limiting me to only this point. The last one is gonna be 2x. And I want to remind you that when we don't have an initial point, it's like saying plus 0, meaning that this starts at, and I'm gonna graph it with color again, but the color is not part of the graph. So I'm gonna start at the origin, and then this says my rise is 2, my run is 1. So I'm gonna go up 1, 2, and run 1. Then 1, 2, and my run is 1. Again, rise is 1, 2, and my run is 1, etc., etc. Okay, so that's where my line would go if it was asking just to graph with no limits. But we have a limit in here, and it's saying that x has to be greater than 0. So this, when x is less than 0, x is less than 0, we're gonna cover that and forget about that part. And one more thing that we have to check for, is this an open or closed circle? It doesn't have the equal sign, so it's gonna be an open circle. Okay, open, not closed. And my line, whenever it's not less than 0 but greater than 0, so this is gonna be my actual line. So the graph for this piecewise equation is gonna be only this part right here, this point right here, and this line right here. The color part is not part of my piecewise graph, okay? You might want to rewind it and see this example again, but I'm gonna give another one. I don't know if you wanna wait. Once you do your homework, you can do one of the two things. You can either erase the colors so that you don't get confused and just see that your actual graph is just gonna be those two lines and that point right there, okay? This is not included in the graph, or you can just leave it, it's okay. I'll understand that you did and that it was just part of your process. Okay? For the next one, it's gonna get a little bit more interesting. And so we have, again, 3 different either lines or points. And so we start again with each individual one. Again, you can do this graph as I do it so that you don't wait there just watching me do it. And I think we'll get to it like this only. So again, blue, pink, and green. So the first one is going to be my initial point, which is going to be at 1, 2, 3, 4. Again, remember that this is not going to be part of the graph, or maybe it will, but we're not sure. My slope is 1 over 1, so it goes up 1 and 1, 1 and 1, 1 and 1. And then just to make sure that we're doing the same thing on both, it will be something like this. Okay, if I didn't have any limits, this will be my line. But it says x is less than -1. So it gets even trickier because it's not even at 0, but -1. So less than are on the left, meaning that you're going to cover up to -1. Again, the other thing that you have to see is it an open circle or closed circle? No equal sign means open circle at -1. And since I'm covering this part, I'm just gonna go on this direction. And it's not perfect, but that's part of my piecewise graph. The next one says that y equals 4. And I'm not going to look at that right now because that looks super confusing. But it's just y equals 4. So 1, 2, 3, 4. That would be my line if I didn't have those complex limits. But now I look at this. When I have -1 is less or equal than x and is less than 1, it means that my x or my graph is between -1 and +1. So between -1, so this is going to be my first point, and +1, so this is my second point. So my line is going to be between those two, okay? The other thing that it says, or that you have to look for, is do I close or leave the circles open? For this one, which is to the -1, we're going to close it because it has the equal sign. For this one, we're just going to leave it open. And hopefully you can see that it is actually open. Okay. Now the last one. Okay, so that's it. That's basically, this wouldn't be part of my graph. It's only this little segment in here with one closed point and one open point. The last one would be my initial point is at 6. So 1, 2, 3, 4, 5, 6. And then the slope is -2, +1. So rise is going down 2. The run is going to the right 1. So -2, +1. -2, +1. -2, +1. So something like this. Again, if I didn't have any limits, this would be my line. However, it says x is greater or equal than 1. The greater numbers are on my right. So, and it says greater or equal than 1. The other thing that I'm looking at is that it's a closed circle because it has the equal sign. So I'm going to close it. And you might say, hey, but that was open for the other line, and that's okay. It's open for this one, but then it's closed for this one. So it's going to be the same point. It's okay. The other thing, again, it's greater than 1, so it only includes this part of my line, not this part. Again, you might want to erase this, or you might want to leave it. It's okay. As long as I see these black parts, that's okay. Okay? So that's the last example. I hope it helps, and now you can work on 11.9.